Pascal Lee has the coolest job in the world, literally. He spent the last 19 summers on Devon Island in the high Arctic. How cold does it get? Just minus 50 Celsius. As a result of his research there, Lee is the first person ever to suggest that Mars has always been a cold planet, and the science is proving him right. Pascal Lee is chairman of the Mars Institute, a senior planetary scientist at the SETI Institute, and director of the NASA Haughton-Mars project at NASA Ames Research Center. He's written a great children's book called Mission Mars, providing kids with a playful and fun guide to packing for a human mission to the Red Planet and what to do once you arrive in sub-zero temperatures. Very important. Lee is also one of the very few people on Earth who can tell you what it's like to wear the latest model spacesuit and drive vehicles custom-made for places like Mars. These are suits and vehicles that may be the everyday norm for future generations of humans. That looks like fun. All right, Pascal Lee, welcome to the show.
Thank you.
Great to have you here. Yeah, I first need to find out, what is the fascination with Mars with you? Has it been a fascination since you were a kid, or how did this all come about with you?
Yeah, I mean, I think that if you step back and look at the big picture of space, if we were like an alien civilization coming into the solar system for the first time, you wouldn't care about Mars. You'd fly past it, and you might take a picture. You'd go for the Earth, because the Earth is the happening place.
Yeah.
It's location, location, location.
Right.
It's not too cold, not too hot. It's got liquid water, it's got life.
Yeah.
And I don't think it's being geocentric to think that really the Earth is the gem in this corner of the galaxy, probably. But we are on Earth. This is our home, we're very familiar with it, and we are looking out into space. And Mars is interesting to us because it's so close to us. Yeah. It's the second closest planet to us. And it's the only one that's sort of, among these Venus and Mars that are so close to us, Mars is sort of farther out. It's colder than the Earth, but not so cold that you don't have liquid water. You can have liquid water on Mars. And you might have life there. And so we are interested in Mars just mainly because we're so curious about who we are.
Well, let's talk about Devon Island. Fascinating, because it really is, you say, the closest thing to Mars on planet Earth. And why is that?
Yeah, well, you know, no place on Earth is exactly like Mars. Right. But if you were to describe Devon Island, it's a remote, isolated island. It's the largest uninhabited island on Earth. It's cold, it's dry, it's rocky, it's windy. There's no vegetation to speak of that you can see. It's scarred by an impact crater. There's ice in the ground. There are ancient valleys that are carved by flowing water that's no longer there.
Sounds like a great vacation place.
But this description, well, I love it because I get the sense of going to Mars every year.
That's true.
But it's really how you would describe Mars as well.
Huh.
And so we have here on Earth this amazing place that is, at the very least, teaching us something about what happened on Mars, possibly.
Right.
How did Mars get its landscape? You know, what happened to Mars over time? And might there be life in a place like this?
Okay, you were also involved in a documentary about what you do on Devon Island, right?
Yes, so
called Passage to Mars.
Yes, Passage to Mars.
Right.
Passage to Mars is coming out in 2016, this year.
Okay.
The thing about this Devon Island place is that, of course, we go there for the science of the place. We try to understand it, but we're also using it as a set to learn how to explore Mars.
Right.
And so one of the things we do is to learn how we might explore Mars in the future with vehicles and people. I mean, should you go out, of course, never on your own, but what's a good-sized group of explorers? How many vehicles should you take on a one-week journey into the wilderness?
Right.
What kind of instruments do you need to take with you? So
that's pretty cool that you can kind of experiment just to see sort of how you might respond and react and what your needs are. We have a clip, actually, from the documentary, so why don't we take a look at that?
Okay, sounds good.
The crew's split up, food's running low. Maybe we've gone one step too far.
It has been a very humbling series of discoveries. We are trying to understand why we even exist.
As we make make our way deeper into the Arctic, the feeling of roving on Mars grows stronger. How far on Mars? How deep into the planet will our search for water and life take us? As usual, when left to themselves, my thoughts turn to Mars and our search for life there.
Altimeter, set 2 knots. We can land this thing up there. Land it? Sure, but we're not going to get it back up.
That was heroic.
All right, that looks pretty harsh out there.
And it's nothing compared to Mars. Mars is going to be the mother of all camping trips. It's the average temperature is minus 60 degrees centigrade. The atmospheric pressure is very low, so if your spacesuit springs a leak, you basically die within seconds, and that's not fast enough.
But is it doable?
It's doable.
It's doable.
It's absolutely doable, and that's the beauty and challenge of it.
Yeah.
It's doable with, of course, a number of things that need to be worked on.
Right.
The spacesuit being a key element. Right now, the spacesuit that we have is too heavy. It's okay to use it in weightlessness in low Earth orbit around the space station. It's okay to even use it on the moon, where gravity is 6 times less than on the Earth. But if you take this spacesuit that we have to Mars, it's going to feel, it weighs on Earth 300 pounds.
Oh, wow.
If you take it to Mars, it's going to feel like it still weighs 125
Oh, so that's still pretty
That's
heavy.
too much.
Right,
50
right.
kilos.
Are you working on that right now to try to adjust that weight?
Yes, we're working on ideas,
Okay.
on technologies to make the spacesuit much lighter than the ones that we currently use, and yet as safe, if not more safe, and yet more capable as well. You have to think of a spacesuit not as clothing, it's a wearable spacecraft.
Right.
So
oh, interesting.
it has computers on board, it has a life support system, radios, communication devices.
But you still have to be mobile. I mean, you have to be able to do stuff.
To be mobile.
Yeah.
You want to climb around, you want to pick
Right.
up rocks, you want to look for life.
Well, let's talk about an actual mission to Mars. It's possible, but I know that there are a lot of dangers involved, including a lot of radiation exposure to the astronauts going and especially coming back. I mean, when they come back, are they going to be like glowing in the dark or have the most awesome suntan or something?
Well, you put the finger on the key safety issue of a human mission to Mars, which is
Right.
radiation exposure. But in some sense, a mission to Mars is fraught with so many dangers that really, if the only thing that will ultimately kill you is a higher risk of having cancer once you're back on Earth because you were subject to some radiation, it's really, I think, an acceptable risk. But we can go over this real quick. The mission to Mars typically is 6 months to get to Mars.
Right.
And then in a typical scenario, you stay at Mars, on Mars, or around Mars for 18 months. That's a year and a half.
Okay.
That's because you can't come back immediately. You have to wait for the Earth and Mars to reposition themselves before you can fly back cheaply.
To be close enough to each other, right? Yeah.
Well, exactly. Well, in the right place for you to come back cheaply. Yeah.
Okay.
And then it's another 6 months to come back.
Okay.
So you spend about a year in total in deep space, going back and forth. And then a year and a half at Mars or around Mars. Anyway, the total dosage that you're going to get radiation-wise is similar to you undergoing something like 100 or 200 CAT scans. Now, that's a lot.
That's a lot.
Nobody undergoes 100 to 200 CAT scans.
Right.
But it's not even mortal. It's not something that would kill you. It's something that, could raise your risk of developing cancer by about 5% compared to the average population.
Okay. So you're saying that's sort of a minimal risk compared to all the other things that could possibly go wrong.
What is particularly dangerous is if there's a solar eruption. These are called solar particle events, a solar flare.
Okay.
And that could essentially represents a radiation storm for you. So for those moments, and they can last a few days typically, you want to be hiding in a well-shielded part of the spacecraft. Good tip for the astronaut.
Exactly. But how would an astronaut protect themselves then from the radiation? I mean, are there ways?
For the day-to-day radiation, the best thing is to put between you and space stuff that contains hydrogen, and that's food and water. Food and water. Water is H2O. It's plenty of hydrogen. Food has hydrogen in it because carbohydrates. Okay. Now, the good news about this, there's good news and bad news with. What you want to do basically is line the walls of your spacecraft with your storage of food and your storage of water. So there's good news and bad news about that.
Wow, okay.
The good news is you drink the water, then you have to go to the bathroom, it turns into urine, but that's okay, you can recycle the urine. We already do that on the space station.
Yeah.
And a few weeks, so you don't take, on this 2.5-year journey to Mars with your crew of 7 people, you don't take all the water you need for everybody. You take only so much water, and then you recycle the water. So a few weeks into your trip, you are drinking each other's recycled urine and sweat.
Yum!
That's the good news. The bad news is the food, okay? We don't recycle food. We eat the food, we go to the bathroom.
Right.
And then
oh, gosh.
food turns to...
I'm really afraid of what you're going to tell me right now.
Exactly. So what do you do with that? You can't just open a window and throw out your feces out into space. That's not good. First of all, you don't have a window that opens. Second, you don't want to pollute space. But the thing is, even your feces still contain hydrogen.
Okay.
Your feces have to be looked at as radiation shielding. So what you need to do is collect your human waste in a Ziploc bag.
No.
Emphasis on lock. And you put that bag back on the wall where you took it in the first place.
Pascal, no.
We don't do this on the space station because the space station right now is inside the Earth's magnetic field. So it's shielded from a lot of radiation. The astronauts do not have to put their poop back on the wall. But on a mission to Mars, you're in deep space.
Okay, that's all right. That's a very nice visual. Thank you so much for sharing.
That's if you want to survive and protect yourself from radiation.
Okay. What do you think? What's the time span, do you think, of when we might see a mission?
The current plan, as far as NASA is concerned, is to get humans to Mars orbit. So without quite landing yet, but to the orbit of Mars by the mid-2030s. And I believe that. I think it's in progress.
Less than 15 years.
It's less. Well, it's about that. Yeah, exactly.
Yeah,
exactly.
yeah.
It's about 15 to 20 years from now. And so I think that's eminently feasible, and we are on course, although extra funding would really help, and I think we should do that. But landing on Mars will take about a few more years after that.
Okay.
But going to Mars orbit will really get the ball rolling, I think.
Right.
And so I see humans landing on Mars in the mid-2040s.
Wow.
So I'll be an older person, but I hope to still be around to see it.
Hopefully you'll be able to witness it. Wouldn't that be exciting?
Wouldn't that be exciting?
Yeah. Well, Pascal Lee, thank you so much for coming in. Such exciting stuff you're doing, and you really are a rocket scientist, aren't you? Man, that's impressive. Thank you so much.
You, May.
All right. Coming up next, looking for life on Mars. It may be closer than you think. We'll be right back.